Hello everyone, myself Ritika Chettipalli from CSC branch section D. Today I am presenting a PPT on topic called Indecency and Adjacency Matrices, Tools for Graph Analysis on course Essential of Problem Solving. First, what is a graph? The graph is a connection between points called vertices and lines called edges. Uses of graphs in economics. In economics, graphs are vital for visualizing the complex relations between economic variables, helping to forecast trends and simplify complex models. In economics relationships, graphs are used to depict concepts such as the inverse relationship between price and quantity demanded, or the directed relation between price and quantity supplied. Forecasting and trend analysis. Economists use time series graphs to track variables like gross domestic product, inflation rates, or unemployment over time to predict future economic conditions. Analyzing complex models. Graph represent complex economic models such as ISM LM, investment saving liquidity money, model making theoretical concepts easier to understand. Demonstrating resources allocation. The production possibility frontiers (PPF) is a classical example of graph that shows the different combination of two goods that can be produced while available resources and technologies. Visualization and inequality. The Lorentz curve uses a graph to show the degree of income inequality with an economic. What is a graph? Graph consisting of vertices called nodes and edges called connection. Graph can be directed or undirected depending upon the nature of the relationships. They are widely used in computer science, social science, and engineering. Constructing indices. Matrix. For each edge, indices identify the vertices it connects and mark the matrix accordingly. In directed graph, entries are often 1 for the initial vertex and -1 for the terminal vertex. In undirected graphs, entries are typically 1 for both incident vertexes. Uses of incidentary matrices. Incidentary matrices helps in analyzing graph connectivity and flow. They are useful for solving problems related to network optimization. These matrices facilitate algorithms like spanning trees and network flow analysis. Overview of indices matrices. An indices matrix represents in relationships between vertices and edges in a graph. It is a matrix where rows corresponding to vertices and columns corresponding to edges. Entries indicate whether the vertex is incident and edge, often with 1, -1, or 0. Introduction to adjacency matrices. An adjacency matrices capture the direct connectivity between vertices in a graph. It is a square matrix where rows and columns represent vertices. Entries indicate the presence or absence of an edge between vertex pair. Constructing adjacency matrix. For each pair of vertices, mark the matrix with 1 if an edges exist, 0 otherwise. In directed graphs, entries can be 0 or 1. For unweighted graphs and weighted graphs, if edge have weights. For undirected graphs, the matrix is symmetric across the diagonal. Applications of adjacency matrices in our day-to-day life. Adjacency matrices are used to determine the degree of vertices and adjacency relationships. They facilitate the calculation of path, cycles, and connectivity with graphs. These matrices are integral in algorithms like graph traversal and shortest path calculation. Comparing indicency and adjacency matrices. Indicency matrices Indicency matrices focus on vertex-edge relationships, while adjacency matrices focus on vertex-vertex relationships. Indicency matrices are more useful for analyzing edges properties, whereas adjacency matrices are better for vertex connectivity. Both matrices provide both matrices provide complementary insights depending on the problem context. Advantages of using matrices in graph analysis. Matrices enable efficient computation and storage of large graphs. They are compatible with linear algebraic techniques for advanced analysis. Matrix representations simplify the implementation of graph algorithm in programming. Limitations of matrix representation. Matrices can become sparse and memory intensive for large spare graphs. They may not efficiently represent dynamic or evolving graphs. Alternative representation like indices lists can sometimes be more appropriate for the specific applications. Practical examples and case studies. Indices, indices and adjacency matrices are used in social network analysis to identify influential nodes. In transportation network, matrices help optimize routes and flow management. Biological networks utilize these matrices to analyze interaction between molecules. Tools and software graph analysis. Popular tools include Networks X in Python, GP, and MAT Labs graph functions. These tools support the creation, visualization, and analysis of graphs using matrix representation. They facilitate the application of algorithms like clustering, shortest path, and network flow. Summary and key takeaways. Indicency and adjacency matrices are powerful tools for representing and analyzing graphs. Understand their construction and application enhances the ability to interrupt complex networks. Selecting the appropriate matrix type depends upon the specific analysis goals and graphs theory. Social network analysis SNA. This is a key technique in sociology where graphs visualize relationship between individuals, groups, or organizations. They are used to study friendships, information flow on social media, collaboration on networks, and community structures. Tracking social dynamics. Dynamic graphs can track how social network structures change over time, showing the formation or dissolution of graphs and socialities. Visualization demographic data. Graphs like historism, pie charts, and specialized maps are used to represent dynamic graph information such as age, gender, migration patterns, and religious composition, often in a geographical context. Modeling population movement. Sociologists and geographics uses flow maps and other graphics to visualize migration patterns and movements of people between regions. Representation statically data. Standard statistical data include bar charts, line graphs, and pie charts are used to present summarized data from surveys and studies providing a clearly understanding of social phenomena. Conclusion and future directions. Advances in computational power continue to expand the application of matrix-based graphs analysis. Integrating matrices with machine learning techniques opens the new research opportunities. Ongoing developments aim to improve efficiency and scalability for larger scale network analysis. Uses of graphs. Graphs are used for visualizing data and relationships in fields like business, science, computer science. They simplify complex information to reveal trends, compare data, and solve problems in areas such as social networks, navigation, and disease tracking. General usages. Comparison. To compare two or more quantities or show how a quantity changes over time. Communication. To present complex information in an easily understandable and memorable way, common in media, reports, and presentation. Computer science and technologies, sciences and medicines, other applications. In computer science and technologies, network representation. To model networks like social networks, the internet, and road networks. Pathfinding. To find the path shortest or most efficient path between 2 points, such as in GPS navigation in Google's. Algorithms to represent and solve problems in areas like data structure, scheduling, and data compression. In science and medicines, chemistry to illustrate chemical compounds and molecular structures. Statistics to display probability distribution, frequency, and other statistical data. Other applications. Business and economics to analyze sales figures, import, export, and other business related data. Urban planning, urban planning and logistics for city planning, traffic control, and managing transportation and transmit systems. Biology to model conservation efforts and track specific movements and breeding patterns. By this, I conclude that in essential problem solving, graphs are very important. Thank you.
సేవ్ చేయమండి ఏదో ఒక వర్డ్.